Here's a second example. And this is a very simple circuit example from elementary physics. If I think about a scenario in which I have 3 resistors connected in an assembly, and say, well, this first resistor has resistance R1, this one has resistance R2, and this has resistance R3, and ask the question, what's the overall resistance of that assembly? The overall resistance of that assembly, elementary physical theory says that it should be R1 plus the product of R2 and R3 over the sum of R2 and R3. And this is an instance of a nonlinear function of inputs R1, R2, and R3, giving me a quantity of interest and output R in the formulation of U being function of xy up to z. The scenario here is that, of course, this is my U, and my xy and z are R1, R2, and R3, and the function is this nonlinear function of inputs R1, R2, and R3. And the question, the statistical tolerating or the probabilistic tolerating question here is, how does the output, if I can tell you about how variable are the inputs, that is, if I have bins of resistors that I'm going to pull R1, R2, and R3 out of, then, and I can tell you something about how variable those bins are, then what have I, R1, R2, R3 coming out of bins being made into assemblies, then what can I say about the variability of the resistance of the assemblies?